Hello, everyone. Obviously, I am not here today. So I recorded this video yesterday so that you could still get the instruction that you're missing today. So I'm basically going to go through the warm up, the lesson notes, and then all of the examples here like I normally would in class. And that should allow you to do the cool down on for today's lesson. So today we are doing jumping ahead to lesson 9 of the Algebra 1, Unit 7. So I'm going to go right into the warm up, which is on slide number 2. So let's take a look at that. Match each quadratic expression in standard form with its equivalent expression in factored form. So if we take a look at that, let's start with A here. Okay, so again, we are going to factor this. So we are looking for two numbers that add up to -2 and multiply to -35. So two numbers that add up to -2 and multiply to -35. So because my product is negative, that means I'm going to need one positive and one negative. And then because my sum is negative, the only way that could happen is if, quote unquote, the bigger number is negative. So in this case, the combination that works is going to be, let's see, -7 and +5. -7 plus 5 is -2, and -7 times 5 is -35. So that means my factors are going to be x minus 7 and x plus 5. So which one is closest to that? It looks like A is going to match up with 3. X minus 7 and x plus 5. So A does indeed match up with 3. Let's look at B. B should be a lot simpler because we have all positives. So we're just looking for two numbers that add up to 12 and multiply to 35. In this case, that's just going to be +7 and +5. So x plus 7, x plus 5. B is going to match up with 1 here. Okay. C. So now we're looking for two numbers that add up to 2 and multiply to -35. So that means I'm going to need, because of this, I'm going to need a positive and a negative. And because the sum is positive, that means I need the quote-unquote bigger number to be positive. So in this case, it's going to be 7 and -5. 7 plus -5 is 2, and 7 times -5 is -35. So my factors will be x plus 7 and x minus 5. So C will match up with 4. And then we don't really have to do anything with the last one because by process of elimination, that means that D will match up with 2. D will match up with 2. So that is our warm-up for today's lesson, just a kind of a wrap-up of yesterday's lesson, a quick review. As far as what we're going to learn about in today's lesson, if we take a look at the lesson notes, we are going to talk about solving quadratics by factoring. And what basically this does is it combines what we've done the last 2 days. So 2 days ago, we talked about the zero product property. And yesterday, we talked about how we can factor a trinomial into its parts. So the first thing we're going to do when we're solving a quadratic by factoring is we're going to rewrite the equation so that it is set equal to 0. All of these methods only work if it's set equal to 0. So I put a note down here that if the equation is not set equal to 0, we have to rewrite it so that it is set equal to 0. All right. So once we do that, we're going to convert the equation to factored form by coming up with two numbers that add up to b, the middle number that's attached to x, and multiply to c, the last number with no variable. So that is what we did in yesterday's lesson. And then once we do that, we can use the zero product property by setting each factor equal to 0 and solving for x. That right here, that is what we did on Tuesday. So with that in mind, let's go to the first set of examples, which are on slide number 4, if you're following along on your slideshow. Okay. So if we look at the first set of examples, okay, we're going to solve the following equations by factoring, by rewriting it in factored form and using the zero product property. So let's start with number 1, which I will do up here. So x squared plus 8x plus 15 equals 0. Okay. So this is set equal to 0 already, so we don't have to do anything with it. So I'm immediately going to factor the trinomial on the left-hand side here. So I'm going to do exactly what I did yesterday. I'm going to come up with two numbers that add up to 8 and multiply to 15. So two numbers that add up to 8 and multiply to 15. So what are two numbers that do that? In this case, the two numbers are going to be 5 and 3. 5 and 3 5 plus 3 is 8. 5 times 3 is 15. So my two factors are going to be x plus 5 and x plus 3. And remember, that is still set equal to 0. So that is what we did yesterday. And then to figure out my solutions, I can now take both of these factors and I can set both of these factors equal to 0. So x plus 5 equals 0 and x plus 3 equals 0. So on this first factor, x plus 5, I'm going to solve that by subtracting 5 from both sides, and I get x equals negative 5. And then for the second factor, I'm going to subtract 3 from both sides, and I'm going to end up with x equals 0 minus 3. So this equation, number 1, has two solutions, x equals negative 5 and x equals negative 3. Okay, so that is number 1. Let's take a look at number 2. So x squared minus 10x minus 11 equals 0. So we're going to do the same thing we did. We're going to factor the left-hand side first. So we're looking for two numbers that add up to negative 10 and multiply to negative 11. Okay, so I know I need a positive and a negative number because this number is negative. In order to get a negative answer when multiplying, I know I need to have at least one of each. So one positive and one negative. And then the sum has to be negative. And the only way that could happen is if the bigger number is negative. So the combination that's going to work here is negative 11 and positive 1. So my two factors in this case are going to be x minus 11 and x plus 1. Okay? X minus 11, x plus 1. Negative 11 plus 1 is negative 10, and negative 11 times 1 is negative 11. Now I can go ahead and use the zero product property. So I can set each of these equal to 0. So x minus 11 equals 0. Okay. And then I could also do x plus 1 equals 0. Okay. So obviously on the left-hand side here, x minus 11, I'm going to add 11 to both sides. So I'll end up with x equals 11 as my first solution. And then my second solution, x plus 1 equals 0, I'm going to subtract 1 from both sides, and I end up with x equals 0 minus 1, which is negative 1. So my two solutions for number 2 are x equals 11 and x equals negative 1. So that is it for number 2. Let's take a look at number 3. So x squared minus 8x plus 12 equals 5. Okay. Notice this equation here is not set equal to 0. It's set equal to 5. And the only way any of this works is if it's set equal to 0. So just like it said in the lesson notes, if the equation is not set equal to 0, you must rewrite it so that it is set equal to 0. So in order to rewrite this so that it says equals 0 at the end, I need to get rid of this 5. So in order to do that, I have to subtract 5, since 5 minus 5 is 0. But if I subtract 5 from one side, I have to subtract 5 from the other side. So the question is, which term am I going to line up the minus 5 under? I'm going to line the minus 5 under here. Why? Because plus 12 is a number and minus 5 is a number. There's no x attached to it. So I'm going to line it up under its like term. I'm going to line it up under its like term. So 12 minus 5 is positive 7. 12 minus 5 is 7. And then everything else I'm going to drop down. So this equation becomes x squared minus 8x plus 7 equals 0. X squared minus 8x plus 7 equals 0. So this is what I'm going to solve here. This is what I'm going to factor. So I'm going to look for two numbers that add up to negative 8 and multiply to positive 7. Okay. For this one, because my product is positive, positive 7, then I know that both numbers have to be positive or both numbers have to be negative. In this case, both numbers have to be negative because the numbers are going to be negative 7 and negative 1. Negative 7 plus negative 1 is negative 8, and negative 7 times negative 1 is positive 7. So my two factors are going to be x minus 7 and x minus 1. Okay. So now I'm going to use the zero product property once again. So x minus 7 equals 0 and x minus 1 equals 0. All right, I'll add 7 to both sides and I'll end up with x equals 7. And then I'll add 1 to both sides on the right-hand side and I'll end up with x equals 1. So those are my two solutions, x equals 7 and x equals 1. Okay. Again, if the equation is not set equal to 0, you need to rewrite it so that it is set equal to 0, just like I did in this last example on this slide number 3. Okay. If you're following along on your slideshow, flip on over to the next slide, and we'll take a look at this example right here. Okay. So number 4, to solve the equation n squared minus 2n equals 99, Tyler wrote out the following steps. Analyze Tyler's work. Write down what Tyler did in each step. So he starts out with n squared minus 2n equals 99. And then in his first step, he goes to n squared minus 2n minus 99 equals 0. So the question is, what did he do to go from the original equation to step 1. It looks like the thing that changed is that the 99 was moved over to the other side. And if you're going to move over 99 to the other side, you have to subtract it. So he had to rewrite it so that it says equals 0 at the end. He did that by subtracting 99 from both sides. So that was what he did in step 1. So that was his step 1, subtract 99 from both sides. So that was step 1. Okay. Step 2. He looked like he went from n minus 11, n plus 9 equals 0. So it looked like he attempted to factor. Let's see if he did it right. So we're looking for two numbers that add up to -2 and multiply to -99. And it looks like the numbers he got were -11 and +9. Does that work? Is -11 plus 9 equal to -2? Yes. Is -11 times 9 equal to -99? It is indeed. So he factored from step 1 to step 2. That is what he did. So he factored n squared minus 2n minus 99. He factored and got n minus 11 and n plus 9. Step 3, it looks like he took each factor and set it equal to 0. N minus 11 equals 0, and n plus 9 equal to 0. So set each factor equal to 0. And then what did he do in step 4? So n minus 11 equals 0. It looks like he solved for n. He added 11 to both sides and got n equals 11. And then he looks like over here he subtracted 9 from both sides and got n equals -9. So that is what he did in step 4. He solve each factor for, in this case, n instead of x. He solved each factor for n and got n equals 11 and n equals -9. So did we answer the question? Did we write down what Tyler did in each step? Yes, we did. He subtracted 99 from both sides. Then he factored the n squared minus 2n minus 99. Then he set each factor equal to 0. And then he solved each factor for n. Okay? So that is what he did in each step. Your cool down for this lesson is going to be a couple of examples similar to this one. So if you followed along, you should be able to do the cool down successfully. And that is what I would like you to do right now. It has already been posted on Google Classroom. So you can turn off this video and go to the cool down on Google Classroom.